Hey everyone. I kind of wanted to explain a couple of things, I guess, for the lesson, so there wasn't as many questions too if I went through it. I am going to go over algebra stuff first, and then I'm going to get into pre-algebra later. So if you're here for pre-algebra, if you want to come back in like an hour or so, maybe 30 minutes, it just depends on how long or how many questions I have, if any. So I know this is kind of impromptu. I was originally planning to do it on Wednesday because of the holiday, but I'm going to go ahead and go over some stuff now because I just had so many questions. So every week you're going to get something similar to this, whether it's a lesson plan basically for the week, and it's going to give you the overview, educational standards, and then the learning topics that we're going over. Especially the part one is going to be kind of like your review of stuff we've already done, and then the part two is like the new extended stuff that we're going to be talking over. It's and then any materials that you need is going to be here. The nice thing about everything with all the blue, they're hyperlinks, so you can literally click on each file, and it'll bring you there. Sometimes there will be paper copies. For example, the guided practice here. If we click this, it's going to take us to the guided practice with the key, and then the independent practice is going to be this PDF. Sometimes you could turn it in just by writing it on the document and then sending it to me. You could also, sometimes there will be a Google form, or there will be a quizzes form that if you have internet, you can put it in there. So please pay attention to the links underneath the lesson plan, and then the new stuff will be the part two, the expansion on new material. And there'll be videos already set up. That stuff will be out on Monday. I still was planning on doing the streams. The schedule, like I said on my last post, is going to be a little wonky for this week just because there's some other things that need to be established, and then once that gets better, I promise that I'll have more of a succinct, more set in stone, I'll use that word, just that phrase instead, schedule, which I will still post. So I know there's a schedule in the bottom right hand corner right now. We can use that one for this week, but it may be different than what's already there, like I said. So this part two stuff is going to be all of the additional new material. You'll have some videos that either myself or Miss King has found or created, and then the notes. The notes will pretty much just be the key, and then you'll have your guided practice and then your independent practice. Independent practice is the stuff you're going to be turning in. I know it's pretty wordy for this, but just read it carefully. You have the whole week to do it. There's not going to be any other new material, so each subject's going to have 1 week of material. So just kind of, if you still have your agenda, have that out, have some sticky notes in place so you know which ones need to be due to submit. I still recommend doing all of it, but I just like that way you know which one you need to turn in and which one you don't. And then the mastery check, that will either be PDF, but if you have internet, like I said, I've posted that. That'll be usually the second or third thing in that assignment. You can just put it in to the Google form. You do not have to do it twice if you have internet. If you don't have internet, that's kind of why the PDFs are there. They're same type of situation. So if you, and then for like the guided practice, there are two things. It's you can do this, which is usually the IXL or Khan Academy. So for the example, if I clicked on this link, this is that would take me to Khan Academy right now. This is just placed in here, so I can't, none of the links are going to work. And then, or you could do 1 through 15 odd, and then there's a key for it to kind of help you with that if you have questions. And then there's some optional stuff, and there's also some enrichment activities below as well. So if you finish all this and you want some more work, or more practice with it, I should say, better yet, there's some Khan Academy or IXL links. There's you can do a few more problems in there. You could ask me for more problems that I can help you with, because I want to make sure that when you take this last thing, the mastery check, that you are good to go, that you understand the material, because this is going to be stuff you're going to see again, especially in Algebra 2. So what I'm going to do now is that I am going to, I was going to go over the notes. So I was going to go through them again. I don't know if that's going to be helpful with having the audio version of it rather than just the copy of the key or what was already up there. So just get a few things into play because Some stuff is out of. And feel free to ask questions because other people may have questions like you did about the material, and they can see it later if they go back to review it. I am just gonna get this set up. And if you are here and you would rather me stop than going over the notes and just do practice problems, I can do that as well. I have the guided practice on this form as well, so we can go over a few of those as well. And I planned about an hour over this, so I'm not gonna waste any time. I'm gonna kind of move through this. So if you have questions, make sure you ask. I'll check every once in a while as we go over this. So a monomial is an expression that is a number or variable or a product of a number and one or more variables. We also refer to that as like a term. And I gave some examples on that key, so I'm going to write that real quick. So that's an expression it's a number, comma, a variable, or product of number, and I'm just going to do just a variable just right now. It could be more than one variable, but we'll just write it for that right now. You also knew that as a term, which I'll write up here. So we also call that a term. And then I gave some examples. I mean, just any number in general, we could just use 5. For a number, for a variable, we can use something like y, v, b, any of the letters of the alphabet. And then if it was a product of a number or a variable, we have something like 6x, or if it was more than one variable, we can have 7 y, b, something of that nature. Or if we had the same variable twice multiplying, you could also have something like 8x, x, and what is that going to equal? That's just going to be 8x squared, so that's another one. Okay, I'm just showing y, but yeah, this is another one that we can deal with, so 8x squared. And then the degree of a monomial is going to be the sum of its exponent. The sum of the exponents of its variables. So the sum of the exponents of its variables. So if I have something like, well, I'm just going to use the example up here. If I just use 5, does that have a variable? Well, it has a variable, but it's not present right there. So it's actually going to be a degree of 0, because if there's no variable there, that means then it's raised to the 0 power, because anything to the 0 power is 1. So that's just 5 times 1, so just 5. So that means you have a degree of 0. That's why that's like that. And then if we have something like y, the exponent is going to be to the first power. So that means then our degree is going to be 1. And then if we have something like y squared, then that's going to be to a degree of 2. But if we have a product of variables, so something like how I had up here was 7yb, so yb, that would be a degree of 2, because y has an exponent value of 1 and b has an exponent value of 1, and when you add those two exponents together, you get 2. So something also like x cubed y second z 7 would be a really high degree of 10, 12. And then a polynomial is going to be a monomial, or the sum or difference of 2 or more monomials. Let's write that real quick. And if you would rather me just go straight into practice problems, I can do that, but I felt like going through the notes may help a little bit, just so you had some audio with it rather than just reading it. So the polynomial is a monomial or the sum or difference of two or more monomials. So an example would be something like 4x squared y. You could have had something like, let's do 2y squared plus 3y minus 1. There was also another one on there where I had two different ones, so I had something like 5y cubed minus 4y plus 2. That's another example as well. And then in standard form of the polynomial, that's going to be when the degree of the monomial terms decrease from left to right. So if something like this, it's already in standard form because we have y squared, y, and then we have y to the 0 power. So that's already in standard form. But I'm going to give you an example if it was not in standard form and how you would reorder that. So in standard form of a polynomial, it's the degree of the monomial terms decrease from left to right. So if we had an example of that, I'm going to write this in purple, so it's just a different color. So example, let's do 3x minus 2x squared plus 5x cubed minus 1. So right now, our highest degree is not in the front, which our highest degree would be x cubed, so our degree of 3 up here. So 5x cubed would be first, followed by our next highest degree, which would be x squared, so minus 2x squared, followed by positive 3x minus 1. So this would be in standard form because our degrees are decreasing from left to right, going from greatest to least. And the degree of the polynomial you will identify as the highest degree. So it's the degree with the greatest exponent. So this is going to be the degree of a polynomial is the degree of the monomial with the greatest exponent. So in our example, is the greatest. So if I was looking at the example right above in purple, our greatest degree value was 3. So that means then our degree for that polynomial is going to be 3. So wow, that was a terrible D. That is going to be a degree of 3 based off our last example. So that helps us with identifying degrees of polynomials. Whoops. So now we also have to identify, though, based off the number of terms. So we have a monomial, and then we have a binomial. So binomial, think of like a bicycle. A bicycle has two wheels, so this is going to be a polynomial with two terms. So a binomial is a polynomial. That should have been closer. Polynomial with the W with the slash means with two terms. And if I'm moving too fast, just let me know. With two terms. So an example of that would be something like a linear equation. Like if we were dealing with something like, you can think of like 2x plus 1. This doesn't have to be, though, with a degree value of 1. This could also be a something like 3x squared plus 4. That can have been a binomial as well. And then if we move one more up, we add another monomial to the polynomial, we would get something like a trinomial, which, thinking of like a tricycle, so 3, we have 3 terms, so a polynomial with 3 terms. So you could have something like 4x to the 4th plus 3x minus 2. We have 3 terms here, so we have, this would be a trinomial. And then I'm going to Alright, so we're done with that page, so I'm going to move over just to the next page real quick. Let's write with this. Alright, so I know this one was a little bit trickier to see since the it was already shaded in on the paper, so hopefully it was easy to be seen with the color that I wrote over it. So they wanted you to find the degree of each monomial. So with this, I didn't explain that one, I just realized. So with 18, does it have a variable? Well, technically it does. If our variable was there, it would be, let's just give it any letter right now, we'll make it an x. It would be x to the 0 power because it needs to be 1. 18 times 1, so this is a degree value of 0. So the degree of a non-zero constant is always going to be 0. And the reason for that, because remember, anything raised to the 0 power is 1. 18 times 1 is just going to give us 18. Now for our next one, we have 3x y cubed. So I'm not going to put in the degree yet. We have 2 exponents, and the exponents on our variables are 1, which is on the x, and 3, which is on the y, so it's y cubed. So if we add those together, you're going to get 4. So because our sum is 4, that means then we have a degree of 4. Alright, next one for C, 6C, we have a degree value of 1 because the exponent value is to the first power. And I'm now realizing that on the notes key, I don't think I've explained this one. So it says, what is the degree of 9x to the 0? And they wanted us to answer that, and that would be, well, we kind of just discussed that with A. We'd have a degree of 0 because the exponent value is 0. And it would just be, and if we were to write that simplified, that'd be 9 times 1, because anything to 0 power is 1, so it would just be 9, and we know that our constants, our non-zero constants, is just going to have a degree value of 0, so our degree would be 0. And I'll put a slash through that. That's another way to show 0, just in case people don't think that's an O. So instead of having to say degree 4, degree of 0, degree of 1, we have come up with other excuse me, terms to classify these degrees. So starting from least to greatest, starting with a 0, that's going to be a degree of 0, that's going to be a constant. We kind of remember that when we're doing multi-step equations, that always the ones that didn't have the variable that was deemed our constant because it wasn't changing. You could also think of that as because like there's no variable to cause an effect to it, so that number was not going to change. Linear, you can think of our linear lines. So that's when you have a degree value of 1. So going back to our linear equations like slope-intercept form, so like 4x plus 3, we would have a linear, it's a linear line, and then when we get to a degree value of 2, we call those quadratics, which we're going to get into later this year. And then if you have a degree value of 3, that's a cubic. And then anything beyond that, you use the number. So a 4th degree, 5th degree, 6th degree, 7th degree, and so on and so forth. In terms of degrees. So anything beyond 4, you're just going to use the number, or 4 and beyond. And same thing with degrees, we also have classifications based off of our terms. So if we have one term, that was our monomial. If we have 2 terms, that's when we have our binomial. And then when we have our 3rd term, that's when we have a trinomial. And then anything beyond that, we usually use polynomial with 4 terms, polynomial with 5 terms. So you just use, again, the number of terms that are already in there if you have any more than 3. So I'm going to scoot this to the next page. So if we were to practice with this, and if I'm moving too fast and you have questions, just let me know. So if we were to practice doing this, and I know you already have the answers because they already posted everything, they gave you all the keys, so I'm just going to kind of go through this a little quick and then we'll do some practice ones together. But so if I was to write each polynomial, first of all, in standard form, combine like terms, then name each polynomial by its degree and the number of terms. So looking at A, we have a constant value, and then we have a monomial here that has a degree of 1, so that we have to reorder this. So the correct form would be 7x minus 2. Now we have to label it based off the degree and then the number of terms. So degree first, going back to that chart, so hopefully you have that in front of you. So we have a degree of 1, and I'm going to try to write this as small as possible. So a degree of 1, so that means then it is linear. And then for the number of terms, we have 2. So having 2 terms makes it a binomial. So we just put those together and we get a linear binomial. That was a terrible box, but so that would be your answer for the for A. So for B, let's go ahead and put it in standard form first, combining our like terms. So we have 3x to the 5th and we have negative 2x to the 5th. So if we combine those, 3 minus 2 is going to give us 1x to the 5th plus 7x. That's our next term. So I'm going to double underline that. And then triple underline our last term. So minus 2. So what is our degree? So looking at our degree, we have a degree of 5. So anything 4 or more, we just use the number. So this is a 5th degree. And then the number of terms. We have 1, 2, 3 once it's simplified. So this is a 5th degree 3-term polynomial. And a 3-term polynomial is going to be a trinomial. So 5th degree trinomial would be the answer for B. All right, C. We don't have to combine anything. We're just going to have to reorder it. So putting our highest degree first, we get -9 x to the 4th plus 6x squared plus 7 in the correct order. So our highest degree is 4. So it's going to be a 4th degree. And then again, how many terms? We have 3, so this is pretty much just like the last one anyway. The degree is different, so it's a 4th degree trinomial. And that's how we got the answer for C. All right, going to D. We have 3 terms right now. Doesn't look like we can combine anything, but we do need to reorder it. So highest degree first would be -y to the cubed plus 3y minus 4. And looking at our highest degree was 3, so this is when we're going to use one of those fancy words, and the 3rd degree is going to be a cubic polynomial, so 3 terms means it's cubic. And we have 3 terms, so it's going to be a cubic trinomial. And then with the last one, we have a 7v and a -11v that we can combine. So -11 plus 7 or 7 minus 11 would give us -4v plus 8. So this would be the simplified standard form. Our degree value is 1. So that means then it is a linear polynomial. And to be more specific, the type of polynomial it is, it has 2 terms. So since it has 2 terms, that means it's a linear binomial. So hopefully putting it in standard form and labeling has helped you out. Excuse me. A little bit with that. So now we're going to go to adding and subtracting. Adding and subtracting is kind of like combining like terms. The only difference is that now you're having to deal with degrees. And because you're having to deal with degrees, you have to understand that you have 9 like terms that have the same degree value. It's the same thing like as if you were going to do volume and surface area. You're not going to combine volume and surface area together. They're different types of situations. Okay, so let me just scroll down a little bit. So when adding your polynomials, you're going to group your like terms and simplify. So group like terms and simplify. And once you've would have been a little bit of a lag there. Once you group them, then you're just going to simplify. So for example, on the first one, see one thing. I think there was a little bit of anyway, so for the first one, we have 7y minus 7x plus 15a plus 3y plus 8x minus 8a. So if I dropped all these parentheses, we would just be adding them like normal terms. So dropping them, I have a 9y. Let's highlight instead. So I got 9y and a 3y. So if I combine 9y plus 3y, I would get 12y. I have -7x and 8x, positive 8x, so if I added those together, -7 plus 8 would give me just 1, so 1x, and we always just write a single variable is just the variable, so plus x, And then last, we have 15a, that's a rough way to do that, minus 8a. So 15 minus 8 is going to give us positive 7a. Okay, and I know I broke that down a little bit different on the note key, so I grouped them all together instead of using the highlighter tool, and I think that hopefully this helps. If it doesn't, I guess write it the other way that I had it up there before with separating it, which I'll do on the next one. So our final answer would be 12y plus x plus 7a. So on the next one, we're going to combine our like terms. So a squared, I don't have another a squared, so 3a squared plus 3ab. So plus 3ab, then we have a positive 4ab, so then we have negative b squared and a positive 6b squared, so negative b squared plus 6b squared. So then combine our like term, they're already grouped together, so 3 plus 4 is going to be 7. And I've already given away the hint for the next one, but it is going to be positive, but negative b squared plus 6b squared is just going to be 5b squared. And that'd be our final answer, so I'm going to write that up. So that would be your final answer. Alright, so that's with adding on this page. Let me move over. A couple more and then we're going to get into subtraction. Subtraction is just a little different, not a whole lot, but okay, so I'm going to speed this up just a little bit just because I'm not going to rewrite them, but if you need to help with rewriting them, that's fine for you to group it that way. I think as we get used to this more and more, we'll be able to move a little bit quicker to it. So add things together that are like terms. So we have 6x squared and 2x squared. They're adding together, so 6 plus 2, because it's a positive, is going to be 8x squared. 3x minus 6x, so 3 minus 6 is going to be negative 3x. 7 minus 4 is going to be positive 3, so that would be your answer for number 3. And then for number 4, we have 4t squared plus 3t squared, so 4 plus 3 is going to be 7t squared. And then we have negative 6 and positive 11, so negative 6 plus positive 11 is going to be a positive 5. So that would be our final answer. And if you have questions, please feel free to ask in the chat. And then if there's anything that's confusing and you don't want to ask it in the chat, you can just email me later. Okay, last one. 3p cubed, 9p cubed, so we add those two together because they're both positive, so that's going to be 11p cubed. Positive 6p squared plus 11p squared is going to be a positive 17p squared. And then positive 10p plus 3p. Okay, awesome. I'm going to go over the guided practice in a minute. I'm going to finish up on this, and then I can go back over degree stuff too as we're doing it. In fact, I should have done that on this one. We can go through that real quick with these 3 problems, and I'll write those to the right. So positive 10p plus 3p is going to be 13p. So you would combine them again, just like terms. Let me see if y'all can see the whole thing. Okay, you can. Okay, so a couple things. Let's go through the naming piece. So when you're naming, you're going to name off the degree first. So what's the highest degree that we're dealing with? And with degrees you have 0, which is a constant. So think of just a regular integer. So like 8 would just be a constant. There's no variable. Well, there is a variable, but it's to the 0 power. If so, let me write this down up here, over here. So you have 0 for your degree. And I know this is already in the notes, but you have your degree, so that's a constant. You have a degree of 1, so that's a linear, so think of like a linear line. So like 4x plus 3, you know, that was a constant line. That was a linear line that we were dealing with. Then we're getting to quadratic, and I'm going to spell this terribly, but I usually, when I was in school, I just do quad, and then 3 would be cubic. Should just go ahead and spell quadratic. And then past that, it's just the number. So I'm going to do 4 plus. So 4 and beyond, you'll just use the number of that's the degree. So for example, if we had 4, it'd be a 4th degree. So 4th degree, 5th degree, 6th degree, 7th degree, 8th degree, 9th degree, all the way up for infinity. I mean, I don't think you'll ever be dealing with anything really more than 5th degree, at least that I can think of right now. You'll have to be naming it, but if we had to, that's what you would use. So for anything 4 or more, you just use the number, degree. And then after that, you're going to label it as the number of terms. And that's where the prefixes come into example. That will help you out with things. So if there's only one term, mono, so that's a monomial. 2 is going to be a binomial. So you can think of you can think of like a bicycle. 3 is going to be a trinomial. So think of like a tricycle. And then 4 or more, that's again, so anything 4 or more, you're going to be dealing with, so a 4-term polynomial, 5-term polynomial, 6-term and beyond. So it's just, it'd be the number of terms polynomial if you have anything 4 or more. So for example, with this number 3, if we were to label this, we're going to look at our degree first. Our degree is 2. That's our highest exponent value. So looking at what I wrote down, we have a quadratic then. So this is going to be a quadratic. This underneath in orange, this is going to be a quadratic. So quadratic, and then how many terms does it have? So we have 1, 2, 3 terms. So this would be a quadratic trinomial. So that's how you would name the number 3. I didn't ask you all to name it, but it just kind of as a review as we were doing this, because this is something new. For number 4, again, go off the degree. So our highest degree is going to be a degree of 2 after you've written it in standard form, which is now in standard form. So a degree of 2 again is going to be a quadratic. And then how many terms? Yes, so the exponent determines the term. No, I'm sorry. The exponent determines the degree classification. The term classification comes off of how many terms there are. So with number 4, and I'm sorry if there's a delay in me answering the question. So with number 3, you have 1 term, 2 terms, 3 terms. For the number 4, you have 1 term, 2 terms that are being combined together. So the degree is going to be the highest number on the highest exponent value. And then the number of terms is going to be how many terms you have there. That's going to be the second word that you're dealing with. So for example, on number 4, the degree value was 2 because it was t squared. There wasn't any other variables attached to this. So then that would be a quadratic binomial because there was 2 terms in this polynomial. For the next one, again, looking at the highest degree, so look at the highest exponent value. That's going to be an exponent value of 3. So this would be a cubic. And then how many terms do we have? We had 1, 2, 3 terms. So that's going to be a cubic trinomial. And what I'll do is I'll label the last 3 on this next one coming up for subtraction too, so we can keep practicing with the naming. All right, I'm gonna scroll down a little bit to subtraction. Now, when I was trying to find some videos for y'all, because I was still planning on doing the stream with it, I did see some other videos that other teachers have done different things with doing the subtraction, and I think the best thing to do is to invert them all, and then add them together, kind of like adding the opposite. Now, I have seen, if y'all are looking out there yourselves, there's also where they stack them on top of each other, and that can sometimes help. I'm going to stick with simply just adding the opposite for right now, just at least on the first go through with it. And I can show you another way to do this, but again, I feel like the adding the opposite's a little bit easier. That way you don't get confused with the signs. The stack method is kind of like going back to system of equations when we were eliminating. So that may look familiar when we do that, but I'm going to just fill this stuff in real quick, doing it by adding the opposite. And I'm not going to rewrite everything that was on the notes because the first thing I told you was to rewrite. So I wrote this and then I rewrote this as adding. Because I'm doing this live, I can do this a little bit easier so I can show you what I'm doing. So I'm going to add the opposite. So I'm going to make this a plus. And then the opposite of a negative is going to be a positive. This is just going to be a negative. And this is now going to be a positive. So that's me rewriting it just kind of quick using the board, and then we're just going to group up and simplify. So we have 9y and 3y, so we add those together. That makes that then 12y. You have a negative 7x and now a negative 8x, so that's going to be a negative 15x. And then you have a positive 15a and a positive 8a, so if you add those two together, 15 plus 8 is going to be 23a. And we'll go ahead and actually name this one because this is kind of a funny one to name. So this is actually already in standard form because the degrees are all the same. So what is the degree value? Well, y has a degree value of 1, x has a degree value of 1, a has a degree value of 1. So we have a degree overall for this problem is going to be 1. So that is a linear polynomial. And then how many terms do we have? So we have 1 term, 2 terms, 3 terms. So it's a linear trinomial. Okay, so that's how you would label it. Now, like I said, I will show how to do the stack method. Again, I would prefer you adding the opposite, but if you want another way to do this to help you out, that's okay as well. So what you're going to do is you're going to kind of set them up just like with system of equations. So I'm going to erase this real quick. Actually, no, I don't need to erase that. I'm going to write the first term, the first setup there, and then I'm going to do the stack method over here. So I got 9y minus 7x plus 15a minus, and the important thing when you're stacking is that the terms need to match up, as in you're already grouping them together. So this was a negative 3y. This was a positive 8x, and a negative 8a. And I forgot the a on there, I'm sorry. So notice again, a's are matched up, x's are matched up, y's are matched up. So they're all together nicely. They're all stacked on top of each other. If you had something that didn't match up, like if there was something missing, then we would just put a 0 there, because there wasn't one in one of those terms, but I think I can show that on a different one. So I'll at least do this at least one other time to show you if there had not been a term that matches up. So then you're just going to subtract like normal, as if you were subtracting. So 9y minus negative 3y, so you'd be adding this point, you would still get 12y. Negative 7 minus 8, so negative 15x. 15 minus negative 8, so you're adding 8, so that's going to be a positive 23. So there is the possibility of messing up with not switching the signs, so just make sure you're careful when you set this up like this. That's why I think it's a little bit better to do adding the opposite, but that's just me. Alright, I'm going to scroll to the next page. I think it's the last one. Okay. And then I do have the guided practice on here as well. Let's scroll down. Alright. So I'm going to do adding the opposite for this one. I'm not going to do the stack method on this one. I'll do the stack method on the number 9, because that's a good one to show that with, where there's something that's missing. Okay, so adding the opposite, I'm going to just change the signs real quick. So this negative becomes a positive, negative 2a, and then minus 6b. So group them up. 5a minus 2a minus 3b minus 6b. So 5 minus 2 is going to be 3a. Negative 3 minus 6 is going to be negative 9b. And that's our answer. If we were to label this, again, this would be a degree of 1, so that's a linear polynomial. And there's only 2 terms, so it's going to be a linear binomial. So on, oh, wrong thing. Move this. Alright, so again, I'm going to just change the signs real quick because this one we're actually adding. Whoops, so I almost made a mistake. So with just adding, you're just going to group up together. So 5a plus 2a minus 3b plus 6b. So 5a plus 2a is going to be 7a. Negative 3b plus 6b is going to be positive 3b. And that would be our solution for number 8. And if you were to label that, again, we have a degree of 1. So it's going to be a kind of gave that one away. It's a linear binomial. And that's why I'm going to try to stream as much as possible. And I'm really sorry I don't have a set schedule right now. Alright, this one again, I'm going to add the opposite, and then I'm going to stack it, just to show you the 2 different methods to see if that helps. Again, if you would rather just add the opposite, I think it's a little bit better. I know it's a little bit more work, but you're going to get to the point that you don't even need to group it out like how I'm grouping it out. You could just do it in your head, and then with the stacking, there's the potential of making a mistake, and I don't want that to happen. Okay, so subtraction, we're going to add the opposite, so minus, plus. Okay. That's a terrible plus. Alright. So 2x cubed minus 5x cubed. So these terms are grouped together. We got a positive 4x squared. I don't have an x squared in this next polynomial over here, so I'm going to then just move over to the next degree. So I don't have an x value, so I'm just going to do minus 2x, minus 6 plus 2. Now you just simplify, 2 minus 5 is going to be negative 3x cubed plus 4x squared minus 2x. Because again, these didn't have anything to combine, and you cannot combine them together. They have different degrees. So negative 6 plus 2 is going to be negative 4. That would be our answer. And if you were to label this, the highest degree, looking at the degree, looking at the degree, your highest degree is going to be 3. So that's going to be a cubic. And then looking at the number of terms, you have 1, 2, 3, 4 terms. So that's a cubic 4-term or fourth term. Yeah, 4-term polynomial. So that's how you would label that one. Now, this next part you can skip if you like the adding the opposite, but again, I'm still going to show how you can do the stack method with this, just in case you would prefer to have that as an option. So again, it's kind of like elimination for system of equations. So I'm going to write my first one, 2x cubed plus 4x squared. I'm then going to write plus 0x. Okay, I know we do not have an x in this one, but if we don't have any, how many do we have? We have 0. So it's kind of being used as a placeholder. Now, if you don't want to write the variable, that's fine. I just would, so you can see that your degrees are decreasing. If you'd just rather make it 0, that's fine as well. I just think it helps just so you don't get confused in trying to combine 0 with 6. That's why I did 0x, because these aren't combining. Then I'm going to do minus 5x cubed. I do not have an x squared term, so I write 0x squared plus 2x, and then minus 2. So 2x cubed minus 5x cubed is going to be negative 3x cubed. 4x squared minus 0x squared is just going to be 4x squared. 0x minus 2x is going to be negative 2x. And then negative 6 minus negative 2, so that's plus 2. So negative 6 plus 2 is going to be negative 4. And did we get the same answer? We did. So that's another way you can do it. Again, I would recommend more of the adding the opposite, but if this way seems to make more sense, that's fine. Just please don't forget about your placeholders, and don't forget to change the sign along as you're going. That negative goes along to each term, not just the first one, because that would be a common mistake when we were eliminating, when we were doing elimination with system of equations. I'm going to scroll down to this last two. I'm going to add the opposite on both of these, so I'm going to change these signs real quick. So I got v cubed plus 6v squared minus v minus, so we're going to make this a plus, negative 9v plus 7v squared minus 3v. So combine your like terms, you have v cubed minus 9v cubed plus 6v squared plus 7v squared minus v minus 3v. Now we're just going to combine them together. So v cubed minus 9v cubed is going to be negative 8v cubed. 6v squared plus 7v squared is going to be 13v squared. And then negative v minus 3v is going to be negative 4v. Alright, so if we were to label that, again, looking at the highest degree, that's going to be a degree of 3, so that's going to be a cubic polynomial, and we have 3 terms, so it's going to be a cubic trinomial. So this would be your answer, and this is if you would have to label it. All right, last one. We have 4x squared plus 5x plus 1 minus um, hello Aiden, 4x squared plus 5x plus 1 minus 6x squared plus x plus 8. So I'm going to add the opposite. So boop, minus, minus, minus. So that was an easy one for us to do. We just have to change the sign for all of them. So 4x squared minus 6x squared. I'm going to loop those together. Again, you do not have to group them up each time like I'm doing it. I'm just doing it to show you what's going on. If you can do this in your head real quick, you can get to the point you don't have to write out all the time. Like you won't have to keep doing it over and over again. So 4x squared minus 6x squared plus 5x minus x plus 1 minus 8. So 4x minus 6x, I'm sorry, 4x squared minus 6x squared is going to be negative 2x squared. Positive 5x minus x is going to be positive 4x. And then 1 minus 8 is going to be negative 7. And that would be your answer for this, but I do want to label it. So just give me 1 second to just get this moved out of the way. Just bear with me just for a moment. Okay, so highest degree is going to be 2. So that's going to be a quadratic. And we have 3 terms, so that's going to be a quadratic trinomial. And that's what you would do if you label it. So hopefully that made sense. Sorry, looking at the chat now. I've been alright. I've been missing y'all a lot because it's not the same doing it from home. So hopefully this is helping some. Some of y'all's emails have been absolutely ridiculous. Made me laugh a couple times, but it's just good. Hopefully you're doing okay as yourself. So I was planning on doing a few practice problems to help y'all out. If that sounds good. I don't know how many people are in here right now. Check. Alright, so I was gonna do some practice problems. Does that sound good to y'all? Hopefully it does. No, it's just math, but I figure while I'm here. Oh, that's not good that you broke your board. What were you doing? I'm sorry, bud. That's not good. So you must be going stir crazy right now with no board. You got your tech deck though, right? You can use your tech deck to hold you over until you get your next board. Yeah, I'm gonna do a couple practice problems. Alright. These are a lot of addition. I don't know which ones I gave y'all, so the guide to practice, just as a reminder, isn't turned in because you already have the key. So I'm gonna go over a couple. Ooh, did you hurt yourself? I'm gonna go over a couple of these, and then I'm probably just gonna go back and forth because they do addition and subtraction, back and forth. So unless there's one specifically you want me to do, I can do that as well. Is there any with 3 terms? Because I kind of would like to do one with 3 terms. No, it's only 2. Oh no, there is. Okay, I'm definitely gonna do at least one at the end. So between 27 and 30, I'll probably pick one to do as well, but I'll stick with the 2 terms for right now. And if you're here for pre-algebra, I'm going to start that probably within the next 15 to 20 minutes, and I'll do volume of that. And then with algebra, I will do more tomorrow. I don't want you to think that I'm just giving up on y'all right now. It's just So like this is going to be going on. What is today? What's today? Tuesday? I'll do another one tomorrow. Probably not as long because like I said, I'm going to try to do some office hours type of situation where you can ask individual questions, and then I'll probably do another lengthier stream on Thursday. So for the first one, like terms, 5p squared, negative 3. 2p squared, negative 3p cubed. Okay, so our highest degree is going to be this 3p cubed, I'm sorry. So that's going to come first, and there isn't another one to combine, so that's going to be negative 3p cubed. Our next degree of 2, 5p squared, 2p squared, and we're adding, so 5 plus 2 is going to be positive 7p squared. We don't have a singular or a p value of p with a degree of 1, but we have a constant, which is going to be negative 3. So if I was to write that out, then finally, that would be our answer. So hopefully that first one made sense. I'm going to pause for just a second to get some water. Alright, so next one, you're just going to be adding the opposite. Again, if you'd rather do the stack method, I'm okay with that. I'm probably just going to be sticking with adding the opposite though, just to make it a little bit easier, or at least to be more consistent. So I'm going to make this a plus, make this a minus, and then the opposite of a negative is going to be then a positive. So a cubed plus they're both positive, so it's going to be a cubed plus 4a cubed, negative 2a squared, negative 3a squared. So then just simplify. A cubed plus 4a cubed is going to be 5a cubed. Negative 2a squared minus 3a squared is going to be negative 5a squared. So that would be your final answer for that. I'm going to scroll down. Does anybody want me to do any more between 1? I mean, I did 1 and 2, but does anybody want me to do any between up to 8? I was going to start with 9 and 10 next. If I don't hear any complaints about not doing any of those, then I'm going to just stick with 9. Alright, I'm going to go to 9. Whoops, wrong thing. And if you want me to go back, I can go back later in just a minute. Oh, number 6. Boop. Alright, okay. Add the opposite. Yikes. Plus, minus, plus, I just reverse the signs. 4r cubed. Oh, whoops, I just made a mistake too. Then you also have 3r to the 4th and then negative r to the 4th, so your degree of 4 is going to come first. Come on now. So 3r to the 4th minus r to the 4th. Then you have your cubed, so that's going to be plus 4r cubed plus 5r cubed. Then you're going to combine your like terms. 3r cubed, to the 4th minus r to the 4th is going to be 2r to the 4th. 4r cubed plus 5r cubed is going to be plus 9r cubed. So that would be your final answer for that. And that would be a 4th degree binomial. So if you wanted to label that, that would be a 4th degree I did not ask you to label, so you do not have to do this. 4th degree binomial. scoot down to number 9. Alright, so number 9, this one's going to have then 3 terms in each of the polynomials. Oh, you know what? I just realized something because I didn't scroll over to look at what exactly is going on. I don't think you can see that because where the chat is. So hopefully that makes that better. I'm sorry, I should have checked that first. So then on the number 9, I'm gonna get my pen. We're just adding, so I don't have to change the sign on these. So we're just gonna combine our like terms. So we have negative 4k to the 4th, negative 3k to the 4th. I'm just gonna add those real quick. So negative 4 plus negative 3 is gonna be negative 7. K to the 4th. I don't have a k to the 3rd. So looking at each term, I do have a k to the 2nd, k to the 2nd. So 3 minus 14 is going to be negative 11 k to the 2nd. Positive 14 minus 8 is going to be a positive, what is that? It's 2, 6. So that would be your answer for that one. And I know I'm kind of going a little quick on those because doing the quick maths with that, but you can use your calculator. So even if you're doing this early in the morning or late at night and you kind of had a lapse in memory on what to do, you can still use a calculator. There's no judgment there for doing that. All right, I'm gonna do number 10 because it's a subtraction, and then I'll probably do number, let's see real quick while I'm down here. Is there one with both? Yes, I'm gonna do number 30 because there's both addition and subtraction there, and I think that would be a good one. Okay, so 10, then number 30. So number 10, we have the opposite signs since we're subtraction, so I want to change all the signs. So make this a plus. Wow, that is a terrible plus. There we go. Plus, plus, plus. They were all negative, so that just turned out to be decent for us. So looking at the highest degree, we have a 5 on our first polynomial. So we got negative 6n to the 5th. Let's see if we have a 5th or anything higher. We do. So we have a positive 8n to the 5th. So negative 6 plus 8 is going to be a positive 2n to the 5th. We have a 4th. So negative 8n to the 4th plus 6n to the 4th is going to be negative 2n to the 4th. So I'm going to cross these off as we're doing them. I know that makes this a little bit more messier. I'm sorry. The next thing we don't have a n squared, so then we have a positive 3n. And then we have just a positive 3. So if I was to label that, or to name that, that would be a 5th degree four-term polynomial. And hopefully the naming is a little bit easier. I know it's new stuff, y'all, so it's a little different, and you're having to remember those words. But the monomial, binomial, and trinomial are just focus on the prefixes there. So like mono, bi, tri, those will help you remember how many terms are there. All right, I'm gonna scooch over to number 30. And I'm gonna make this just a little bit smaller in there because I'm gonna deal with zooming in. Okay. So Since we're just adding on this left portion of it, I don't have to change the sign, but we are subtracting, so I'm going to go ahead and change those signs. So I'm going to make this a plus, this a negative, and make this a negative. Okay, so this is now just a negative. So then we're going to group everything together. Looking at the highest degree, so x to the fourth, y to the fourth, this degree would be a degree of 8 because it's 4 plus 4. You want the amount of total exponent powers that are together on the monomial, so this would be 4 plus 4, which is 8. But we have x to the fourth, y to the fourth, and we have another one here and another one here. So I'm going to underline those real quick. So we have negative 7, positive 4, negative 6. So I'm going to write those real quick. And this is a lengthy problem, so don't freak out just because you don't understand. This is more of an involved one, and you won't be asked something like this on the so the mastery assignment, the Google form that's at the bottom. There's going to be one that's a bonus question. I think that's number 4 that has 3 trinomials, but it won't be as intense as this. I'm pretty sure it has something. It's just no more than like x squared, y squared type of situation. You won't have this as intense of degree. Alright, so then our next degree is x to the fourth, y to the third. That'd be a degree of 7. So we have here, nothing in the first one. We have one here and then one here. So I'm going to put those together. So negative 10 x to the fourth, y to the third, minus, I know it's really tiny, but I changed that sign there. X to the fourth, y to the third. So these are good. I'm going to double underline those. Now I got those. And then the last thing you have is y to the third, y to the third. So we're going to triple underline those to know that I'm done. So I got plus y to the third plus 6y to the third. All right, and then just combine. So negative 7 plus 4 is negative 3x to the fourth, y to the fourth. Negative, oh, whoops, you know what I forgot? I forgot this negative 6 down here too, so I need to erase that because Mr. Parker made a mistake. All right, let's try that again. So negative 7 plus 4 minus 6. Negative 7 and negative 6 makes negative 13, plus the 4 is going to make negative 9. You could have also had this as negative 7 plus 4, which gives us negative 3. Negative 3 minus 6 is negative 9. It's another way you could have added those or combined those. Negative 10 minus 1 is going to be negative 11. And then y to the third plus 6y to the third is going to be plus 7y to the third. So if I was to label this, which I would not ask you to do, I think is intense in this, something as crazy as this, because this is going to be a high degree. Our highest degree is going to be as we said before, is going to be a degree of 8. So this is going to be an 8th degree. And then how many terms do we have? We have 1, 2, 3, so an 8th degree trinomial. But again, you didn't have to label it. I just asked, I'm just added this to it and ask for y'all to do that. I'm adding this to that. So that's just another thing you can do. If you have more questions on the guided practice, please ask them. But I'm going to ask for you to pause on asking those until tomorrow. If you could, please pay attention. I'm going to make the announcement probably in the morning. I have a meeting at 10, so it will probably be an afternoon stream as well. And like I said earlier, there may be times where I have to pause just for a second because of there's a call center situation going on where we're having to answer other questions. So don't take offense if I have to pause for a second. I will, it'll be briefly, and then I'll edit that out at least when I make the final edits for that. So if you have more questions, write them down and make sure you don't forget, and we can ask those again tomorrow. And it will probably be around the same time. It'll probably be closer to 1:30. And then also, if you'd like, I made a mention as well. The PBS channel is doing, I guess, reviews, and I don't know, have a whole lot of knowledge of this, but they are doing, I think between 2 and 3, they're doing review for science and algebra topics. So if you happen to miss the stream, that's another option as well. And I'll try to at least do the stream around those, so you won't, if you want to still watch those and miss this and visit this, then that's fine as well. But I'll have a more definitive schedule starting next week. I know it's a little wonky right now. I miss you all a ton. I'm gonna switch to pre-algebra now, so if for algebra, if you want to come back tomorrow, that's cool. If you want to hang around and review on volume, that's fine as well. I'm going to back out for a second. I'm just going to go get some more water, and then I will be back. So I'm not ending it. I'm just going to be right back in just a second.